Okay, so we're going to evaluate limits when we don't have a picture. So in this case, we have the limit as x approaches -1 of 5. Well, this is kind of like saying, let me see here. This is like saying, oops, I didn't mean for that to be a highlighter. Sorry about that. Okay, so this is like saying f of x equals 5. Well, if you were to look at the picture of that, right, here's your xy axis. We'll just say that that right up there is 5. So f of x equals 5, let me do this in another color so you can see it a little bit better, would be this line right here, right? There's f of x, aka y, right? F of x equals 5. So what's the limit as x approaches, oh my goodness gracious, if I could get that thing to be an f, we'd be all right. As x approaches -1, well, let's say this is -1. Well, if we look at this, we can see that the limit coming from the left is approaching a y value of 5, and the limit as x approaches -1 from the right is also approaching 5. So then we can say that this limit, as is, would be 5. So that's our answer. Now, here's the cheater method. Okay, I'm going to tell you that anytime you have a limit, it doesn't matter what it's approaching. If it's a constant, that answer will always be that constant. So if this was the limit as x approaches -2 of 7, then that would be 7. Okay? Now with number 1, I drew a picture because it was pretty easy to draw an equation of f of x equals 5. But some of you may not know exactly what this looks like, and to be honest with you, without me plugging some numbers in, I really would kind of have a hard time as well. So what you can do is, the way of doing this when we don't have a picture is we would start by trying to just plug that number in for x, so here and here. So I'm going to go ahead and I'm going to do that, and so I'm going to do 2 cubed minus 2 squared minus 4. And then I'm just going to work that out. So this is going to be 8 minus 4 minus 4. So my answer is 0. Pretty straightforward, right? All right, now I'm going to do the same thing with number 5. So I'm going to plug in a 3. So 3 plus 3. And that is going to give me the negative square root of 6. I just kind of added a little extra example right here. I want you to look at this question. Now, if I initially just plug in that 4, what I end up getting is 4 minus 4, which will give me the square root of 0, which I know is just 0. So at first glance, you would say, oh, okay, the answer is 0, right? But I want to take a look at this graph here. And square roots are kind of a special case, because if we look at this, ask yourself, what number can I plug in here? And I would make what's underneath here a 0. And that would be 4, right? Okay. So now also remember what a square root picture looks like. So if I'm drawing a square root, it goes through 0, 0, and it goes like this normally, right? But I have minus 4, and it's technically underneath this square root, so it's kind of in parentheses. So remember, sorry about the phone call. All right, now I forgot where I was, but I think I was saying that when you have x minus 4 here, remember if it's underneath, in this case it's underneath a radical, it's kind of like being inside parentheses. And so then you should recognize that that is a shift. And that's actually a shift in the opposite direction when it's in parentheses, or in this case under a radical. So my picture is going to start at 4 instead of at 0, 0, and it's still going to behave like a radical would. Now, so this is what I'm talking about here. So let's look at this. So we have the limit as x approaches 4. Here's as x approaches 4, and we got 0. Well, that does make sense. If you're coming from the right, do you see that my y value is getting lower and lower, and it's approaching 0? However, remember, if a limit's going to exist, and there's no little plus or minus to the right of the number, this means you have to take into account the limit coming from the left and the right. Well, the limit exists coming from the right, but look over here. There's no graph here that's coming from the left. So at first glance, if you plug in this 4 and you get 0, people would say, oh, it's 0, when in actuality, that is incorrect. So your real answer and your correct answer is not 0, it's D and E. Okay, so it's not 0. And again, it's not 0 because we don't have the left part of this graph. There is no left part that approaches the 4 from the negative direction, or if it was coming this way or whatever way it's coming. We don't have a graph coming from the left-hand side of x equals 4. So we say D and E. So my suggestion to you is when you have a radical, please be very careful. Up here in number 5, when we had a radical, we plugged it in, we got a number, no problem. It's when you get 0 that you want to say, and then everybody should know that if there's a number underneath that radical, that's telling you there's a horizontal shift in the opposite direction of this sign. And just sketch it, and you'll see that coming from the left, it doesn't work. Okay? All right, so for number 7, I'm going to plug in 1. Now I have a negative, let me put my pen on there. I have a negative fraction, and then I'm just going to plug 1 in the top. So that's 1 minus 4 over 1 squared, which is 1, minus 6 times 1, which is 6, plus 8. Right? All right, and then I'm going to work that out. So that's going to be negative 3 in the numerator and a positive 3 in the denominator. And oopsie, what else did I forget to do? Let me just change my pen color here. And you should see that this negative that I had right here, I forgot to bring that through. So I'm going to put it there in red so you can see it. So I have a double negative there, right? So my answer will actually be a positive 1. And there's your answer. All right, so then let's look at number 9. Okay, so remember what pi really is. Pi is really just 180 degrees, isn't it? Okay, so there we're looking for the limit as x approaches pi of the sine of x. So we are going to try to find the sine of 180 degrees. Now remember, 180 degrees is over here. The coordinates are -1, 0, and sine is the y value. So my answer would be 0. And let's look at number 11. Okay, so number 11, I'm going to plug in that 1, right? So I've got negative, and if I plug in 1 into the numerator, 1 squared is 1 minus 1, and in the denominator I have 1 minus 1. Now look at that. So that ends up being 0 over 0. Do not say that that is undefined. That is not undefined. Undefined is when just the denominator of a fraction is 0. Here you have the numerator and the denominator that are 0. So remember what we call that. That's called an indeterminate. And I'm just going to abbreviate it. Indeterminate. Now when we have that, we got a problem. You can't write your answer as an indeterminate. So if you remember when you did limits last year, if that happens and you end up with an indeterminate, what you're actually going to do is we're going to start with the problem again, okay, as x approaches 1. Let's keep that negative there. And usually what you can do, and in this case you can factor the numerator and sometimes the denominator as well. Sometimes you do both. In this case, though, you can see that that denominator doesn't need to get factored, so I'm just going to leave that. And in the numerator, I've got dots, so that's x plus 1, x minus 1. Now, the reason why we do this is you notice that we have a common term here, a common factor. And when I have a common factor in the numerator and the denominator, I can cancel them out. And the reason why we do that then is I can take this value of 1 and now I can plug it in and I will not get an indeterminate. Okay, so again, indeterminate can't be an answer. So I've got negative, and then I've got 1 plus 1, and the denominator really is a 1 because these factors cancel each other out and create a 1. So my final answer is -2. Okay? Right, the same thing's going to happen with number 13. If you plug in that 2 into the numerator, I'm going to get 2 squared, which is 4, minus 2, minus 2. And in the denominator, I'm getting 2 minus 2. So there's your indeterminate again, 0 over 0, which we can't have. So then we're going to rewrite that limit as x approaches 2. Let's keep that negative in there, not forget that. And let's factor out that top. So that's going to be x minus 2 and x plus 1. And in the denominator, x minus 2. So you've got your common factors right here of x minus 2 and x minus 2. So we can cancel those out, rather. And now I can plug this 2 right here in right there. Okay, so when I plug that 2 in, don't forget that negative that was in the front, and 2 plus 1 is 3. So the final answer is negative 3. All right, so when we're doing a piecewise function, it's a little bit different. Let's start by looking at the number, that we're approaching. So we are approaching as x approaches negative 1, but from the negative direction. So the first thing you want to do is figure out what domain this is in. So these both have negative 1, but we want from the negative direction, which means numbers that would be less than negative 1, right? Because we're coming from the left-hand side. That's what this means, from the left-hand side of negative 1, which would be like negative 2, negative 3, negative 4. So then you ask yourself, okay, does this include negative 2, negative 3, negative 4? I hope you're saying no. Aha, but this does. So if this includes the numbers to the left of negative 1, then that is where I'm plugging this negative 1 in. I'm going to plug in a negative 1 right here, and that will be my answer. So I'm going to just write it down here. So I have negative x minus 3, and that's where I'm going to plug in, a negative 1, right? So I've got negative 1 minus 3. So that's 1 minus 3, which is negative 2. Okay? And again, just to repeat, I am not plugging that negative 1 here into this bottom part because this is saying to come from the left-hand side of negative 1. Numbers that are less than negative 1, which this does not include numbers that are less than negative 1. All right, so we have another piecewise function. Now this one's a little bit trickier because this doesn't say from what direction. So if the limit as x approaches 1 doesn't say like from the negative side or from the positive side, we have to look at both sides. So we have to look at numbers that are less than 1, and then we also have to look at numbers that are bigger than 1. Well, right here, this piecewise function, this part of the piecewise function, has numbers that are less than 1, and this part of the piecewise function has numbers that are greater than 1. So what that means is, when we have to approach both sides, that means we have to plug this 1 into both things, okay? All right, so let's start by doing that. So if I plug in 1 into the top here, and I'm just going to go like this, I have 1/2 plus 9/2, right? And 1/2 plus 9/2 is 10/2, which is really just 5, okay? All right, then here, if I plug in 1, I'm going to get 1 squared, which is 1, minus 6, which is negative 5, plus 10, which is also 5. So, do you see that these guys are the same? Okay, so what that means is this is your limit coming from the left because we're approaching 1, and this domain encompasses all the numbers that are less than 1. So in other words, to the left of 1. So this is the limit coming from the left. Then the limit coming from the right would be the numbers that are greater than 1, which would be this part of the piecewise function. So your limit from the left equals your limit from the right, right? So that means the limit exists. This is asking what is the limit. Since both of these guys are the same, then your answer would just be 5.